Okay, so let's continue our discussion on pointers, right? As I told you, we'll try and conclude it today, maybe in the next 30 minutes, okay? So just to remind you that the last in the last week we started this discussion, right? And I told you that the simplest way to define a pointer is that if someone asks you what is a pointer, it is simply a variable which can hold an address, right? This is the simplest possible way to define a pointer. So if you remember, we started our discussion with something like this. I told you that, okay, suppose you have some variable like an integer. So whenever you define an integer and give it a value, it stores some, you can say, space in the memory, right? And typically integer is 4 bytes. So somewhere in the memory, 4 bytes are reserved for you and the value you have there is 5, okay? But you know that every location in the memory has a unique address, right? So it means that when you are storing this 5, it will have some address, okay? So if we are interested in that address, so we discussed last time that you have this operator ampersand, right? If you use it with a variable, you have to read it as address of, okay? So we were reading it as address of x. So if I simply write, I want to display it something like this, so it will say address of x, and address of x is this 5000. So if you write, you see this on the screen, okay? And I also told you that do not confuse this when you are doing call by reference. If you remember, in call by reference, we do something like this, okay? So you have to remember that since we have a limited number of symbols, so the interpretation of a symbol is different depending upon where it is appearing. If this symbol appears in function prototype, it means we are talking about call by reference, okay? If the same symbol appears with a variable like this, you have to read it as address of, okay? And then we said it is not very useful that I just keep on printing addresses, right? I need to do better than that. So for that, we define something which is called a pointer. So how do we define a pointer? You simply, just like you define a normal variable, right? You simply put this symbol, which is this star or asterisk, whatever you want to call it, right? So again, you see, if you use it something like 2 into 3, now we know that it means multiplication here, okay? But now when you are defining and you are using this syntax, so you have to read it, as I told you, from right to left, okay? So how do you read it? You have to read it from right to left. So you say p. What is p? P is a pointer to an integer, okay? So you read it in this direction. P is a pointer to integer. So in other words, this star is read as pointer when it is appearing in a definition. And if this does not make sense to you, what does it mean p is a pointer to integer? So a simpler way is we just define what is a pointer. You can also read it as p is a variable which will hold address of an integer, right? This is the simplest way you can explain what this statement is. P is a variable which will hold address of any integer, right? So in our program, we have only one integer, which is x. So it means in P, which is a variable somewhere in the memory, if I write this, so address of x was 5000, so this 5000 actually goes here, right? And we also discussed that since P is also in the memory, so P will also have some address, but for the time being, we are not bothered about it, okay? Let's not discuss it. It is there, but for the time being, we don't need it, okay? So this statement, P is assigned address of x, will do this, you get 5000 here. And now if you write C out P, so you again get the same value 5000, okay, which you were getting with this statement. Okay, so this is something we had done last time. And towards the end of the discussion, I also told you that you see, if you are interested in printing the value of x, so one way is that you will simply write, say, C out x, right? But if I want to print it using this P, okay, not using this x, then I told you, you again have to use this symbol, but now this symbol will have a different meaning, okay? Now you don't have to read it as pointer. Here in the definition, you read it as pointer, okay? And you read it as P is a pointer to integer. But now when it is appearing with a pointer variable in a statement, now how do you read it if it is like this? So I told you how to read it. You have to read it as contents of whatever is in P. Or in simple words, P has 5000. So in order to understand, in the beginning, you can do something like this, right? Because P is 5000, so I can write it like this just for understanding purposes, okay? So you have to read it as contents of 5000. Now, where is 5000? This is 5000. What are the contents of 5000? 5. So it means if I write this star P, this will give me value 5. Okay, so this is another way of accessing the value, which is an indirect way. I can directly access the value of x, which is 5, but I can also access the same value using this contents of operator, right? You have to read it as contents of. And after static, you always use a pointer variable. You see, p was a pointer, so that's why we can use it. And just to give you some more insights, right? So from this discussion, you must have guessed that both of these things are actually same. Okay, if I write address of x or I write p, both of these are same and they will give me 5,000. Similarly, both of these are actually equivalent, whether I write x or I write static p, they will both give me this value 5. So both of these are addresses, right? These are addresses and these are values, right? They are actually referring to the same location, so that's why you get the same thing. And they both are referring to the same address, so that's why we get the same address, which is 5,000. Okay, so now you see, it is also possible that we can use a pointer to assign a value to the variable. Okay, so let me just come here, because here we have this memory. So you see, this p is 5,000, and we know if I write static p, okay, it is saying contents of 5,000. So it means I can also write something like this. Suppose I call it 102. Okay, so what will happen is, now see this carefully, what is happening. We said static p and x are the same thing, so it means this statement is same as writing this. Okay, both of these are actually the same thing. Why? Here you are directly assigning a value to x, you are saying x gets the value 102. Here you are doing the same thing, but you are doing it indirectly. Okay, you are saying contents of 5,000 will get the value 102. So let's suppose I don't write it, I just write like this. Okay, so this is what contents of 5,000, and you say they get the value 102. So this is 5,000, and you are saying I want a new value which is 102. Okay, and now if you write something like cout x, so now since you have changed the value, you will see the new value, which is 102. We did not change it using the variable x, but we changed it using the variable p. Okay, so now let me quickly write this program on Visual Studio, and then I'll take your queries if there are any, right? So I'll shift to Visual Studio, and then we'll be writing this small program. Okay, so I think now you can see the Visual Studio. Okay, so let me just clean it from some previous programs. Okay, yeah, so now I say there is an integer x which gets a value 5. I want to store its address, so I say I take a pointer p, right? And you have to read it as p is a pointer to integer, or in other words, p will hold address of an integer. So now it means this is a legal statement. I can copy the address of variable x in p. So if the address of x is say 10,000, now p has the value 10,000. So let's try different things. Okay, let's say address of x. Okay, and let's print it using this operator. Okay. Now we do the same thing, but this time instead of using this, I will be using p. Okay, and we just want to see whether we get the same thing or not. So I again write address of x, but this time I write p. That is something like this. Okay, so it means both of these should give me address as we discussed. Now let's try also print the values. So I write value of x. One way is direct way, where I can write simply x, and the indirect way is that I say contents of whatever is the address of x, right? So these are you can say two different ways. Okay, so now both of these should give me value of x, and both of these should give me the address of x. So I'll run this program. Okay, let's see if it works, and I'll share with you the output window. So let me show you the output window, which is here. Okay, so now you see we have address of x. This is printed with address of operator. This is printed with p. So you are getting the same thing. Okay, this is the address in the memory where x is lying, and then this is the value of x. Okay, value of x means that when you print it using cout x, and when you print it using cout static p, so you are getting the same thing. Okay, but if you run this program multiple times, maybe this address will change. Okay, you will not always get the same address, because every time a different memory location can be assigned. So that's why if you run it multiple times, it is very much possible, rather it is likely that every time you will get a different address. Okay, now let me just change the value of x using pointer as I told you. Now suppose I write static p is say for example 100. Okay, now what we are doing here, we are simply saying contents of 5000, they get the value 100. In other words, with this statement I am actually changing the value of x. Okay, and just to see if it has changed or not, in the next line I will write value of x and I will print x. Okay, so I have indirectly changed the value of x to 100 and I want to see whether the value is changing or not. Okay, so let me run this program. Okay, I'll share with you the output window, and here's the output window. You see, initially value of x was 5 and now you see address is also changed as I told you. So when using p, I change the value of x. Now x has the new value. Okay, so I did not use x to change the value. I actually used p, but it is working because we are actually changing the same memory location, right? So this is the program in front of you where we have seen it in detail on the slides on the board, and now you have seen the output as well, right? So if you have any queries related to this, please let me know. Else we'll quickly have a function with pointers, right? So please, if you have any confusion, let me know. Okay, now we have some basic knowledge of pointers, right? We already know what are functions. So the last thing we'll see is how we can use pointers with functions, okay? And before I write an example, I'll just tell you that you have already seen call by reference and call by value, okay? So when we are using pointers with functions, it is very similar to call by reference, okay? In other words, when you will be changing something in the function, it will be affecting the original variables in the main program or from where you call the function, right? But how does it happen? We'll see in detail, okay? So I'll make a very simple function, the same example which we had done with call by reference, right? If you remember, we had done something like we have a function in which we need to add and subtract together, right? So if you remember, we have a function say add subtract, in which I did something like this, say integer, and then I said you can have by reference two variables, right? And these are actually the inputs. The first two are actually the input and the later two are actually the outputs, right? Because if something is by reference, what we do is we change their values in the function and you are actually changing the variables in the main, right? So now I'll slightly change it, that because we are not doing call by reference. Now what we are trying to do, we are trying to do call through pointers, okay? So I just told you that you see how to define a pointer. You write something like this, okay? And if you define a simple variable, you do something like this, okay? So I told you last time that this is variable x and this is your data type, okay? So int is your data type and this x is your variable. Now if you apply the same thing here uh, to, to when you are declaring a pointer, so this p is your variable and what is your data type, this whole thing. So when you are writing int pointer, this is your data type and p is your variable, okay? You can always compare it with int x. So it means if I have to pass an integer to a function, I write int in the prototype because the data type goes into the function prototype. But if I have a pointer, what is data type? Data type is int star, right? So what I will do is if I have to pass pointers to a function, this is how I will write, okay? Because you know int star, it means pointer to integer, which is actually the data type in which we are interested, okay? So the first new thing we have seen is if we want to pass pointers to the function, this is how you actually define the function prototype, okay? So let me just clean this so that I can get some space, okay? Right, so now let's quickly come back here. So let me just write some main. It would be similar to our previous example so that you can always correlate. So if you remember, we had two integers, say x is 2 and y is 3. Okay. Then we also took two integers to store the result. So we say sum is 0 and difference is 0. And we actually want the function to compute this. Okay, I'm not calling this function yet. Okay, I'll call it here. But before calling this function, let me also start writing its definition. Okay, so I'll just split the board and let me just write here void add subtract. Okay, and then I write int a, int b, and you simply copy the prototype, you simply add variables. Okay, so I just copied whatever was written here, but I have also added now variable names. Okay, now before we can write the body of this function, I think it's better we draw a chunk of memory and we should know what is actually going on in the memory, right? Because without that it will be very hard to understand. Okay, so let me just draw it here. Okay, so far we have in the main we have four variables. We have x, y, sum, and difference. All of these four variables have some values, so let's call them 2, 3, 0, 0. But one more thing we should add is, since we are dealing with pointers, so it's a good idea that we also write the addresses of these locations, right? We don't know the exact addresses, but let's write some random number. Okay, so maybe this location is say 6000. Since this is 4 bytes, so the next one would be 6004. Then this would be 6008. Okay, it is not necessary that they are contiguous, right? 4, 8, right? But just for simplicity, I'm writing like this. It is possible this is at 6000, this is at 10,000, and so on, right? But just to keep it simple, I'm writing like this. And then let's call it 166020. Okay, and then maybe I don't have space here. Okay, so let me just do like 6024, and let me make one more 6028. Okay, and let's draw one more chunk because we'll need four more variables. Okay, now you see when you call the function, now is the important thing. What happens when I call this function? First I need to know how to call this function. So to call a function, we write name of the function, add, subtract. The first two are integers, so it's really simple. You simply write x comma y. What happens is x goes to a, y goes to b. So in other words, I have a here, I have b here, and then I have s here and d here. Okay, let me change the pen. It is very light, so maybe this one would be better. Okay, so this x actually goes to a, so it means a gets the value 2. This y, it goes to b. Okay, if you remember, it simply goes to b, so b gets the value 3. Now the important thing is, how do I call this? How do I pass this? For example, what is this s? S is a pointer. In other words, s is a variable which needs an address. So you cannot pass a value here, right? You need to pass an address, and the address of which variable? Suppose I want to pass this sum. So we already know how do we get address of a variable with this operator. So when I write this, what is this? Address of sum. What is the address of sum? This is sum. Address of sum is 6008. Okay, so this address of sum will be passed to this s, and this is, it makes sense. Why it makes sense? Because s was also expecting an address. So you see, when you write like this, we say s is a pointer. In other words, s is a variable which needs an address of an integer, and we are doing the same thing. We are passing address of an integer. So when you remember from previous discussion, and sum means address of sum. What is address of sum? Address of sum is 6008. So that 6008 goes to this variable s. Similarly, now you can guess the next one is also a pointer. So I write something like this. Now what happens? Address of difference. What is address of difference? Address of difference is 6012. So it means this D will get the value 6012. Okay. So let me just write them so that they are more visible. B, this is S, and this is D. Okay, similarly, this is X, and this is Y, and here we are calling the function, right? So this is a very critical statement, so please spare some time to look at it. I'll explain it again. When we are calling a function, so the first two variables were simple integers. There's a conventional way. I want X to be copied in A, so I simply write X comma Y. X goes to A, Y goes to B, and this is what is happening at the back end. Value of X is copied in A, value of Y is copied in B, 2 and 3. Okay, now the next argument is a pointer, which means S requires an address. Okay, we cannot call it like I write sum here. This will be wrong because you are not passing an address. In order to make it an address, we have this operator which is called address of operator. This statement means address of sum. What is sum? Sum is here. We assumed its address is 6008. So when you call this function, the address of S goes to this variable S. So that's why you see in S, I have copied 6008, which was actually address of this variable S. Similarly, when I write address of difference, what is the address of difference? It is 6012. It goes to pointer D. So D is now containing 6012. And now we have to write something here. Okay, means we want to assign values to sum and difference. Okay, but I cannot do this. This statement will be illegal. Why it is illegal? Because in this function I only have 4 variables A, B, S and D. So it means I cannot access this variable. Okay, it is out of scope. I can only access 4 variables which are like A, B, S and D here. So it means that these are the 4 variables which you see at the bottom of the memory chunk, which I can access from this. Now we don't have the variable sum, but we have this address 6008. So somehow using this address or S, we have to assign it a value. And if you remember from your previous discussion, we just said that you can access the value by dereferencing a pointer or by using this static operator. If I write this, if you remember, if I write this, if you read it, what is this? It is saying contents of 6008. You read it like this, contents of 6008. So it means if I change its value, what am I doing? I'm saying add A and B, 2 plus 3 is 5. And then you're saying contents of 6008, which is this statement, it gets a new value, which is 5. So it means here you can write a new value, which is 5. Similarly, if I do the same thing with D, okay, so I can write something like maybe steric D is A minus B. So you are saying contents of 6012, they get the value A minus B. A minus B, 2 minus 3 is minus 1, so they get the value minus 1. Now you see when the function terminates, you come here, you say see out sum, see out difference, they have now new values. Okay, so you can print sum here, you can print difference here, and this function has changed the value. So it is very much the same effect that we had when we were dealing with call by reference, that if you change something in the function, it is affecting the original variable. But what is happening here is different in terms of what is going on at the back end, because here you are passing an address, and then in the function you are saying, okay, go to that address and change the value. So here you are indirectly changing the value. And now you see someone was asking that why we are indirectly using, because here we cannot directly use it. We only have one option, that is S. So this is the advantage, that now I can indirectly change the value of these variables sum and difference, because I cannot directly access them here. Okay, so with that I'll take a pause, right, and then we will have some discussion. So basically we are trying to do an example where we'll be you can say computing the square of a number as well as the cube of the number within the same function, but we'll be using pointers. Okay, so let me just make some function, say void f. Okay, and this is the number for which we want to compute the square and the cube. And the next, this one is by pointer, because in this we want to compute the square. And here we'll be computing the cube. Okay, so let's write the main for it. So in the main, we take an integer, say a, which is Okay, and then we need to call this function. Okay, so even without writing the body of the function, we should be able to call it. But before that, we need to take some variables in which we can store our answer. So let me just take two more variables that I'll be passing to the function using pointers, right? So we take a variable, say square, and we take another variable, say cube. And now if I have to call this function, you can simply write name of the function, right? The first one is integer, so you simply write a. The second one needs an address, so it means you have to write address of some variable. And then the third one is also an address, so I write something like this. Okay, and at the same time, let's start writing the body of the function so that we can correlate both of these and discuss further. So here I'll be writing the body of this function, say void f. We call it, say, int x. Then we have a pointer, we call it p square. And then we have another pointer, we call it pc. Okay, and as always, just to understand things better, okay, so initially we have some variable a which has value 2. We also have square, we did not give a value, say there's some garbage value. We also have a variable which is called cube. Okay, since we did not give any value, so we don't know what is there. Now when you call this function, what happens is that we have three new variables created. One is called, say, x, the other is ps, and the third one is pc. And each of these has some address, so let me write those as always. Okay, so when you call this function, this value of a, it gets copied in this variable x, right? So it means x will get the value 2. Similarly, when you write this, we are writing address of square. Now this is square. What is the address of square? It is 5004. This goes to the second one, which is ps, so it gets the value 5004. And then you have this address of cube. This is the variable cube. The address is 5008. So this 5008 comes here. Okay, now this is what happens when you call this function. We have not yet written anything within the body of the function. Now to this variable square, I need to assign value a into a, or 2 cross 2, right? Means which is the square of a, which is 4. So here the value of a is in x, so it means I want to compute x into x, which will be 4. Okay, I compute 4, but where this 4 should go? This 4 should come here, and within the function I have only these three variables. Okay, you see, these are the three variables which I can access from the function. This one I cannot access any of these variables because these variables are defined within the main function. So we see we don't have the variable square, but we have address of that variable 5004. So as I told you, how can you assign a value to this? You can say contents of 5004, they get a new value. So all, you know, for contents of, you have this operator. So when you write like this, you are saying contents of 5004, they get the value 2 into 2. So it means this will get the value which is 4. Similarly, if you have to compute the cube, you want to assign to this variable, you have its address. So you say contents of 5008, they get the value of x into x into x. So you can write x into x into x. Okay. Now when this function terminates, what happens? All of these variables are destroyed. They are no longer in the memory. You come back here. And now once you come back here, you simply write, say, cout square. Now what is square? This is square. It has what value? It has 4. So this 4 is printed on the screen, right? Sorry, I forgot to write. This is 8 here. Similarly, once you write cout cube, then it has value 8. So you see 8 on the screen. So now you see it is very much similar to what was happening in function call by reference, where you are simply passing these two pointers you are changing the variable values within the function, and the main you have those new values, right? Because you directly went to this address and copied the value. So what is happening is that when I print square and cube, I get the answers which have been computed by this function, right? So this was just one more example to illustrate how you can use functions with pointers, right? So now if we have any problems related to this, please let me know. Or maybe first let me write a program, okay, and then I take your queries. So let me quickly write the program for this, and then we can have a discussion. Okay, so let me just get rid of this. So I'll make a function, maybe similar to the one that we just saw. So let's make a function. I think we can make the one which was doing add and subtract, right? So I write void add subtract two integers and then two pointers. Okay, and within the main, we take just like we did, say x is 2, y is 3. Then we have integer sum is 0 and difference is 0. Okay. Now, before calling this function, let me write the body of this function. So we have void add subtract int a, int b, pointer s, and pointer d. Okay. So now when I will call this function, what do? We pass x and y. Okay. But since the next two arguments are pointers, so we need to pass an address. So we know this is address of this variable sum and this is address of this variable difference. And here you can write sum, and here you can write something like this. Okay, now let me write the body of this function. So here we know that this s is containing address of variable sum. Okay, so if I want to assign it a value, I'll simply write sum is a plus b and d is a minus b. Okay, so sorry, it's not sum, it is s. Okay, let me try run this program. Okay, so now you can see the output window, right? When we have two variables x and y, which are 2 and 3, we are indirectly adding them, we are getting 5, and 2 minus 3 is minus 1. Okay, but the important thing is that we did not do it directly with the variables. What we did was that we had these two variables where we were passing them to passing their addresses to the function, and then we were indirectly manipulating their values, right? So this was one example, one complete working example. You have seen the output, right? So I think now if you have any problems, please let me know.